In this video, we're going to do a quick crash course on how to write formulas for ionic compounds, both binary and ternary ionic compounds. So once again, ionic compounds are compounds that contain a metal and a non-metal. That's if they're binary. And if they are ternary, they would contain a metal and a polyatomic ion. And so what we're going to do is we're going to take a look at how to write a formula from a name. So if you're given a name, can we convert it into a formula? We're going to start off with the binary compounds, and then we'll do it with the ternary compounds as well. The rules are very similar. You just have to pay closer attention with ternary. So let's do a few examples together with the binary first. So here we have magnesium chloride. If I want to write a formula for magnesium chloride, here's the general setup. First, you write the symbol for the metal on the left side, and you put its charge on the top right. Its charge can be obtained from the periodic table. You look at what group it's in. Magnesium is in group 2, has 2 valence electrons, wants to lose 2, so it becomes +2. Chlorine is in group 17. It has 7 valence electrons. It wants to gain 1, not lose 7, gain 1, so it's -1. And then what you do is you crisscross these. We call that a crisscross. You circle the charges, and you bring them to the opposite sides and the bottom. So -1 would go to the bottom of where magnesium is, and +2 would go to the bottom of where chlorine is. And so that will look like this: Mg -1 Cl +2. You then get rid of the signs. You don't need those anymore. So we have Mg 1 Cl2. And when you have 1, you don't need to write it anymore. It's implied. So we can just write this as a nice final cleaned up formula, Mg Cl2. That's writing a formula for a simple binary ionic compound. Sometimes there's an extra rule you have to follow. We'll do it in this example here. We'll write the formula for magnesium oxide. Same idea. We'll have Mg +2. The charge of oxygen to group 16, 6 valence electrons, wants to gain 2, not lose 6, so -2. We're going to do the crisscross as we did before, just like that. And we'll get Mg +2O -2 +2 here. Then we can drop the charges Mg2O2. Now, you'll notice that this is not as simplified as it could be. You want to treat it like a fraction. For example, if you had 2/4, you could make it 1/2. You want to simplify it as much as possible. So we can simplify this by dividing both small numbers or subscripts by 2. And that would give us Mg1O1. And since they're both 1, we can clean it up to get MgO. So if you can reduce, make sure you do reduce. You always have to have whole numbers at the end, so you can't have a decimal value. But if you can reduce, make sure you do reduce. And that would be how you write a formula for an ionic compound. Let's try another example here. So we'll do aluminum oxide. You can always pause the video and try it yourself. So aluminum is in group 13, has a charge of +3. Oxygen is in group 16, has a charge of -2. Crisscross these, and you get Al -2O +3. Remove these signs, Al2O3. Notice you can't reduce anymore. 2 and 3 are as simple as they can get. Let's now try aluminum nitride. So similar idea. Aluminum is a charge of +3. Nitrogen is in group 15. Doesn't want to lose 5, but wants to gain 3. So -3. You can crisscross these, and you'll get Al minus 3, N plus 3. Then you can remove the signs, and you'll get Al 3, N 3. You'll notice this can be further reduced by dividing by 3 here, dividing by 3 here, and you get Al1, N1. And since these are ones, you don't have to write them in. You can simply put Aln, and that is aluminum nitride. So Aln, aluminum nitride. We'll try one more. Let's do lithium sulfide. So same process. Lithium is in group 1, that's our metal, plus 1. Sulfide's in group 16, so like oxygen, has a charge of -2. Let's crisscross that, and we get Li minus 2, S plus 1. We can drop those charges, Li2, S1. Notice that they're as simple as you can get, so you don't have to divide, but you have a 1 next to S. You don't have to write that out. It's implied. It means we know it's there, so we can just put Li2, S. So we just wrote some examples of binary ionic compounds from name to formula. Now we'll take a quick look at ternary ionic compounds from name to formula. So let's say I have lithium sulfate. You need to realize you have a ternary ionic compound by looking at the name. You have sulfate there. The 8 indicates that you have a polyatomic ion. If you don't remember which polyatomic ion that is, you would go to your reference table and find that formula. Sulfate is SO4, 2-. So to write a formula, here's what you do. The first step is the same as the previous examples. You write the charge of the metal. Then you put your polyatomic ion in brackets, not its charge, but all the atoms. So sulfate is SO4, and I'll put the charge on the outside, okay, the -2 over here. And now I'm just going to crisscross. I'll bring the +1 to the outside there on the other side, and the -2 right there. Just make sure you're bringing the other number to the outside of the bracket. Don't change anything that's on the inside, otherwise you change your polyatomic ion. And so you'll get Li -2, SO4 +1. You can drop the signs, so you get Li2, SO4, 1. Since there's a 1 here, you can actually remove the bracket and the 1 and simply write it as Li2, SO4. If there was any other number, you couldn't remove it. You'd have to keep the number there, and you'd have to keep the bracket there as well. Let's try another example. We'll do calcium phosphate. So again, you'd have to recognize that you have a ternary ionic compound. We have calcium and phosphate. Phosphate is the polyatomic ion in our compound. So we'll write our charge. Calcium's in group 2, +2. That's for our metal. We'll put our polyatomic ion phosphate, PO4, in brackets, and its charge on the outside, -3. We'll bring the -3 down to the other side, the +2 down to the other side and outside the bracket, of course. And then we get Ca -3, in brackets still, PO4, +2. From here, we can remove the signs. So we get Ca3, PO4, 2. We can't reduce at this point. 3 and 2 are as reduced as you can get. And we can't remove the bracket because, well, there's a 2 there. So you cannot remove the bracket. Let's try another example. We'll stick with calcium again to keep it nice and simple. Calcium. And then we'll go with sulfate. Calcium sulfate. I know this is a ternary ionic compound because it ends in 8. And most of my polyatomic ions end in 8. There's a few exceptions. Take a look at your reference table. So calcium sulfate. To do that, calcium is charge of +2. Sulfate is SO4 -2. Remember to keep the atoms themselves in the bracket and the charge on the outside. Circle those charges and crisscross them. and you'll get Ca minus 2, SO4 plus 2. You can drop the charges, the signs, so you get Ca2, SO4, 2. Notice the 2 and the 2 here can be further reduced by dividing by 2. Do not divide anything in the bracket by 2. Just divide what's outside the bracket by 2 there. Okay? What's inside has to stay the same. And you'll get Ca1, SO4, 1. Since these are both 1s, you don't have to write them in. And since you have a 1 where the polyatomic ion is, you don't have to put its bracket anymore. So you can simply put Ca, SO4. And that is how you write a formula from a polyatomic ion, ternary ionic compound from its name to formula. We'll do one more example together. Let's do aluminum nitrite. Now remember, this is not aluminum nitride, IDE. If it was nitride, that would simply be ALN because IDE is the indication that you have a binary compound. This is a polyatomic ion here, nitrite. Aluminum is in group 13, so that's plus 3. Nitrite is NO3 in brackets minus 1. Circle those charges, crisscross them, and you get Al minus 1, NO3, 3. Plus 3. You can drop the signs, so Al1, NO3, 3. And since there's a 1 where the aluminum is, you don't have to write that 1 there anymore, and you can clean it up as Al, NO3, 3. You can't remove the bracket for the polyatomic ion because there's a number other than 1 on the outside, so you have to keep it as is. But you can remove the 1 from the aluminum since you don't need that 1 there anymore.